Okay, in previous part, we learned how to convert an analog filter into digital equivalent system using BZT. Now we just want to use direct design of digital IIR filters in Python. Now, digital Butterworth. The first topic is related to digital low-pass Butterworth. Use the specification in equation 7.33. F of S sampling frequency 8 kHz, passband frequency 2 kHz, delta F 800 Hz, attenuation in stop band 40 dB, and ripple in passband 0.1 dB. Now we are going to run the program inside PyCharm. Okay. Now the results. Here you see the location of the poles of Butterworth low pass filter. The degree is equal to 20. Okay. And this is the frequency response. Here you see the declarations. Low pass filter, no ripple in passband and stopband because it's Butterworth. And the computation here, the degree is estimated to be 20 and the rest of the parameters. Okay. Now, this is the code. And here you see Butterworth. Okay. N and WN is computed as signal.Butterworth, WP, WS, AP, and AS. Okay, AP and AS. And this time analog is false because we are going to use directly the syntax. So, estimation of the degree and then using the filter design. Num and denom will be equal to signal.butter. Okay, N, WN, B type low pass filter, so low, and still analog false. Okay, now the rest is just how to plot the result. Now, high pass for Butterworth, of course. Okay, let's run the program. Now this time you see a high pass filter. Of course, the type is Butterworth. Here you see the passband and here you see the stop band. Now, declaration 40, 0.1, 2800 and 8K. This time, the stop band frequency will be FP minus delta F because a stop band frequency is less than the F passband frequency. It's high pass. So, WP, WS the same manner. Estimation of the degree the same manner. WP, WS, AP, AS, analog false. And print the degree. Just going back to PyCharm. The degree being equal to N suffices. Now, the design, major design, num and denom will be equal to signal.butter N normalized frequency range WN, and this time B type is high. Okay, and analog is still false, and the rest is similar.